ending the polling now. So you are in the screen, and hopefully you are able to do this. So what I'm doing is I'm scrolling with my mouse, and I can zoom out and zoom in. The first important thing that you need to know is whatever drawing you're going to be doing. So I go and I check so this file is there on Blackboard. You go to week 2 weekly plan, you will see ASTM Type 1 here. So that is the file that I've opened. And I see that the drawing units are in millimeters. So that's the first thing you need to do. So you go back, then on the top left here, well, I can actually close this entire thing. So let me close this. There we go. So in the left here, you have document settings. So you open that and then make sure your units are the same units as in your drawing. So it is millimeters here, so ensure that you're in millimeters. Next, couple of things. So on the top right, there is this help bar, which should pop up now. So if you click that, there are some very, very good support documentations here. You can do show learning panel, and there are quick tips and modeling essentials, and this is another way to learn Fusion 360. If you go click your name up there and go to preferences, then a page will open up that tells you your general preferences. You can set a lot of preferences here, but the important thing that I want to show here is your pan, zoom, orbit shortcuts. By default, this will be at Fusion for you. I use SolidWorks controls because I prefer SolidWorks. I'm more experienced in SolidWorks, so I use SolidWorks as the pan, zoom, and orbit controls here. So I click SolidWorks and I click OK. So being in SolidWorks control, what it allows me is if I press the middle mouse button or the scroll wheel and rotate, I can then rotate it. So this is the same way the controls are in SolidWorks software. If I press Control and the middle button and then move left and right, then I can pan. And then left is selection. So I have nothing to select, but left is for selection. So that's the controls I'm familiar with, but whatever controls works for you, works for you. Now there's another thing, students always ask this question for me. Why are we using Fusion? Why not SolidWorks, or why not NX, or why not CATIA? So I have a short story for you guys. I started learning CAD software during my undergrad more than 10 years ago. And there was this software, cute little software called Pro-E. And if you ask me where that software is, it's nowhere. It was bought out by another company, PTC Creo, and Creo has so many different versions now. So what I want you to get from this class is you're learning how to design, how to manufacture. You're not learning a software. Softwares come and go. So you might be the expert in SolidWorks, but what happens in 5 years when SolidWorks is not there? Or SolidWorks has been completely updated to look like a completely new, different software. So you're learning how to design, you learn how to manufacture. So that's one reason why we intentionally force you to learn a different software. So I know Mech 100, if you have completed Mech 100, you used NX there. So hopefully this is a different experience with Fusion. So that gives you an idea of how different softwares work. Another reason why we are using Fusion is its CNC feature, or the CAM feature, the manufacturer feature, is very powerful and easy to use. So that's another reason why we are using Fusion. Third reason is Fusion works in Mac as well as Windows. That's a great reason to have Fusion. Fourth reason, it's completely cloud-based, so it's best for virtual environments like the one we are in. So that's why we're using Fusion. All right, so that's a great advertisement for Fusion there, even though I prefer SolidWorks. So let's get started. So the first thing we do to make this part is we need to create a sketch. So the way I'm going to make this is create a sketch and then extrude it. There are many ways. There are multiple ways you can make this part, but this is the way I'm going to be making it. I'm going to be doing it step by step, slowly, really slowly. If you want me to slow down even further, please type in chat, raise your hand, turn on the mic, and ask me. Okay. So the first thing I'm going to do is create a sketch. So on the top left, there is this create sketch section here. Another thing about Fusion is if you keep hovering over something, a help panel opens up. So I click create sketch. The first thing it's asking is, excuse me, which plane you want to sketch in. So sketch is a 2D thing. So it's asking for which plane. So I'm going to choose the bottom plane here, which is actually, we can look from the top. So I select the bottom plane, and then it automatically moves to a perpendicular view of this sketch. So we come to this screen. If I click the middle mouse button and then rotate, if you're in SolidWorks controls, then I can rotate and you can see that I've moved here. Another important thing to note here is if you click the home button here on the top right, you'll come to an isometric view. But when we are in a sketch, we want to be in the top view right now. So I click top. There we go. But that is unfortunately the opposite of top. So I click the left button there, and there we go. So now I am in the right view. So hopefully you learn by doing these things. Is everybody following me? Well, I'll do a small thing. So the first thing I want to do now is I want to create the big rectangle, outside rectangle here. I see the dimension as 165 by 19. So 19 by 165. So I go back to Fusion. I want to create a rectangle. So on the top left, there's a 2-point rectangle there. So I click that. I start at the origin because I know where that is, 0, 0, right? So I start at the origin. Then I make an approximate rectangle. It does not necessarily have to be the same size. I make an approximate rectangle, right? So there we go. So now we have 2 lines that are black in color and 2 lines that are light blue in color. Can someone type in the chat why these 2 lines are blue and these 2 bottom and the left line are black? If you have gone through the tutorials, you should have known that, but you can take a guess as well, even if you did not go through the tutorials. Can someone please type in the chat why these 2 lines are black and the other 2 lines are light blue? Great. So we have Paige saying blue means it is not fully constrained. That's correct. So the black dark lines means it's constrained, and blue means it's not fully constrained. It's good design practice to always have everything constrained. So how do we constrain this? So we know the dimensions. That's how we're going to be constrained. So what I'm going to be doing is on the top, we have sketch dimension. So you click sketch dimension, and then I click the top line, right? Then I know that line needs to be, I forgot. Let's go back. There we go. That needs to be 165 millimeters. So I type 165 and I hit enter. There we go. So the right side line now became black because now that's fully constrained. Now the top line, so then we need to give the height. Remember the height is 13, but let me check again. The height is 19 millimeters. So 19 millimeters. So and then I press enter. There we go. So we have the outside rectangle now fully made. So I hope everyone has been able to follow me. I'm going to do a poll again to let's do too fast. So the question is, am I going too fast? So I want your responses on the poll there, please. Ooh, one yes. So let's see here. Oh, okay. It's great. Great. More than 20 of you are saying I'm not going too fast. If I'm going slow, that is understandable. Many of you have design experience before. If you are comfortable with Fusion already and you can create this part on your own, go for it. You can go ahead of the class and start making the part. The drawing file is available on Blackboard, so you can do it there as well. But if you want to follow me, I will be giving some tips and tricks here and there, so you can follow me as well. So great. So now we have the outside. So now we have the outside rectangle done. Let's move to the inner rectangle. So there's an inner rectangle in there that has a length of 57 millimeters. Okay, let me close the poll. There we go. 57 millimeters and height of 13 millimeters. So I'm going to create an inner rectangle. Okay, we have a chat message from Amber. Amber, that's completely fine. You don't have to worry about that. I can understand the connection. There might be connection issues. That's why this session will be recorded and posted. So hopefully you get a chance to see the video. I will post another video explaining how to do design as well. So you don't have to apologize for that. It's great. So thank you for informing me. I completely understand. So I'm going to create the inner rectangle now. I'm creating it approximately. Again, 2-point rectangle, then I create an approximate rectangle there. I do sketch dimension. So now you see that it's all completely blue and we need to make it black. So I do sketch dimensions. The top width is going to be, I forgot, okay, go back, 57 millimeters. So I do 57 millimeters, perfect. Now the height needs to be now 13 millimeters, if I remember correctly. So 13. So that's good. Now the way you come out of sketch dimension, you can press the escape button and then you will come out of sketch dimension. So now I will be able to move this rectangle, but it's still not fully constrained. Whereas you will not be able to move the dark rectangle, the outer rectangle. So the inner rectangle you'll be able to move because it's not fully constrained. So we need to fully constrain it. But how do we constrain it? So one thing, if we go back to the drawing, we can see that the total length is 165. The inner rectangle's length is 57. So what would be the distance of the inner rectangle from the left side? We can calculate that. It is going to be 165 minus 57, and the answer divided by 2. So you can do the calculation yourself, or what I can do is I click sketch dimension. From the left side, I click the left side line, and then the left line of the inner rectangle, and then so this, the length of that needs to be, you can give mathematical formulas here. So I open bracket, it's going to be 165, and you subtract 57 from that. You close the parenthesis, and then divide that by 2. All right, and then I click enter. It calculates it for me. It's 54, right? And now we have these inner two lines. The vertical lines for the inner rectangle constraint now. Similarly, we can do for these, the distance between the bottom two lines, and that needs to be 19. I'm sorry, I need to open brackets. So 19 minus 13 divided by 2. Right, so we had to calculate that, and it does the calculation for us, and there we go. So it's 3 millimeters. So it did the calculation for us. The reason why I showed the way. Okay, Megan, you have a question?
So the section you just did where you distanced that line, yes. So I'm noticing that spot where you put the end of that rectangle. I assume that's where the arc that you're going to put in ends, or is that line distance
Yeah.
going to be just the line, not the arc included?
So the next step is going to I'm going to be creating the arc, the tangent arc. So these are the inner lines. Yes.
Okay.
So and there are multiple ways you can do this drawing. This is the way I found the best way to do, but I'm not the world's biggest CAD expert, right? So there, and that's the good thing and the bad thing about CAD, the sense that you can make the same part using multiple different ways. So if you have a preference of a different way, go ahead and do it that way. Okay, so you don't have to. For me, I understand most of you have already taken Mech 100 and are very proficient in CAD. The reason why I go this slow, at least on the first class, is some of the students are new to catering or new to CAD or from a different major, business major, chemical. So they might not have the Mech 100 experience. So that's why I do it this way. Also, it's a good refresher. So thank you, Megan. Thank you for the question. I appreciate that. Um, so I hope everybody has been following me till now and has been doing this step by step as I'm doing this as well. You will need this part for future projects. So I want you to be doing this along with me step by step. All right. So next we have, if we go back to the drawing, we have the inner rectangle and the outer rectangle, but we need now the arc up here, the tangent arc up here. So how do we create that? Go create a tangent arc. So on the top, you go to create, and then you click the down arrow there. Then you go to arc, and you will see something called a tangent arc there. So it says it creates an arc with tangency. That's exactly what we want. So I click that. Now you select the point where you are going to have the tangency. So I'm going to zoom in into the inner rectangle's bottom left corner. So that's where the tangent is going to be. I select one point there, and I select another point on the bottom line, bottom rectangle's line. Okay, I don't worry about the radius for now, but make sure it is on the bottom rectangle's line. Then you click on that line. There we go. Now you see that it creates a constraint there that says it's tangent, but the line is still blue in color. That's because we have not set the radius for it. So I click sketch dimension again, then I click the line again, and then it asks for the radius. I forget the radius again. So go back to the drawing, and I see the drawing says the radius is 76 millimeters. So I create one with 76 millimeters. There we go. I hit enter. Voila. So we have a dark line. That means it's fully constrained, and we have the tangent arc done there. Similarly, what I'm going to be doing is make 3 more tangent arcs. So go to create, arc, tangent arc, bottom right, click that, and then make sure I click it at the bottom rectangle. That's good. Now, if I don't hit the escape button, I'm still in the tangent arc menu. So I can keep creating again. So top right, and then top line there. So another arc there. And I'm not worrying about the radius for now, right? Because that's intentional. So this is a faster way to do it. And now I hit escape. So I have all 4 tangents, but only one of the tangents is in the right dimension and fully constrained. Now I want to show you a simple trick here. There are these constraints on the top here. You can do different constraints. You can actually see that some of the lines are horizontal, vertical. Those are the constraints that you can see in grayed out. So what I'm going to be doing is I'm going to be doing an equal construction. So I click the equal button. I click the tangent arc that was already dimensioned first, and then I click the bottom right tangent arc. Now what it does is it makes the diameter of the right tangent arc equal to the one on the left. So, and you see that it's fully constrained now. I can do the same thing. I click the bottom right one and then the top right one. So now that's equal. Now I click the top right one and the top left one, and it's equal. And you can see that an equal constraint shows up on top of the line as well. So that way now we have everything constrained. Now I click escape so that I come out of this panel. The reason why we do it this way is, let's say your design changes, and now your radius is going to be 85. So instead of changing each and individual every tangent arc and changing it to 80, you can 85 whatever. You can simply change it here directly, and then now all the tangents automatically change. So that's why this is a good practice to do. But again, we need it at 76, so I'm putting it back at 76. Click enter. There we go. I think we have dimensioned everything now, if I remember correctly. There we go. Wait, still doesn't look like the way I need it. There are some unwanted lines here in these rectangles. How do we get rid of these unwanted lines? What I'm going to be doing is, there is a command called trim. So on the top here, we have trim. So I click the trim button. So it's an intelligent trim. So it tries to intelligently trim the unwanted parts. So I don't want this line here. So if I click this line in the middle, top middle, it removes that. Give some warnings. I'm going to ignore the warnings for now. Then the bottom outer rectangle middle portion of the line I don't need. So I click that. There we go. Goes. That looks like the dog bone that I want. Oh, wait a minute. There are some inner lines. So there is the left line of the inner rectangle that we created, which we don't need. Let's select that. And then the right line, select that. There we go. So now we have the part, even though there are some unconstrained stuff, but we have the overall shape that we needed. So I'm going to ask another poll here, because we are going to be moving to the extrusion portion of this. Okay, there's going to be another poll, so please answer the question. Okay, there are a couple of you still not done with your sketches, so. Okay, so Amber says she is stuck on getting the correct dimension for the tangent arc. So the first thing you do is select the bottom left point. Okay, you can start it and get it. Okay, read the chat. Who else is having issues? Amber and Spencer. Okay. My connection cuts out once in a while. You can't change the value. So to change the value, you need to go sketch dimension. Okay, Spencer, that's great. So if your internet is a little bit slow, yes, that is fine. You can follow the lecture and then you can complete it. But if you're having trouble, email me. Okay. So, so Megan, if a value shows up in gray, click on it and it should open a dialog box. Yes. So Megan is giving good instruction as well. So one thing you can do is you can click sketch dimension and then click the tangent arc, and then you should be able to set the radius that way. Another thing is, if there is a dialog box already, then you can double click it and then you can edit it that way as well. So hopefully that helps, Amber. I'm going to be moving on, Amber. I hope that's okay with you.
That's fine. Go ahead and I'm still following. It's just that's gonna stop me for the moment.
Okay. So this session is recorded, so maybe if you missed it, something you can go back and check it. Okay. So once we are done with the sketch now, on the bottom right there is Finish Sketch. So you can click that, or on the top right there is another button called Finish Sketch. So you click Finish Sketch. There we go. Now obviously it doesn't look like we moved from a sketch to a different thing, but we have moved, and the way you know that is on the top right there is nothing that says Finish Sketch. So this is an important confusion in Fusion. It is not apparent that we have moved away from the sketch portion. So another important thing is we will always be in the solid portion. On the top left, you can see there is surface, there is sheet metal. We will not be using any of these things. So remember, we will always be in solid portion of the portion for the class. So the next thing we want to do is create an extrude of this. So I click extrude, and then it automatically selected the sketch that I have here. So it wants it to be, it's asking for the thickness of the extrude. If I remember correctly, the drawing said the thickness is going to be 3 millimeters. So that is the thickness of the part. So I'm going to go here and then hit 3 millimeters. There we go. Then it's creating a new body, which is what we want, and then I click OK. There we go. So we have created the dog bone design right here. That's wonderful. So I hope everybody is following me right now. This dog bone is what we will be using to do a class activity on Wednesday to do some CNC manufacturing.